Namaste everyone. Hope all of you are well. This session, our school is going to reopen. It's a very nice thing that we are again coming to back to school, tuitions and everything, because the suffer of lockdown all over the globe has been suffered, and especially if I talk about in the educational field, maximum loss has gone to the students. But yeah, really, yeah, online interaction is good, but whatever the things would happen by face to face, that is not in the things of online education. Yeah, but then also teachers and students have tried their level best to understand and make them to understand. So this is the video especially of ionic equilibrium. If I talk about this ionic equilibrium, then I talk from the equilibrium. Whatever the things we have studied in the equilibrium. Equilibrium has been divided into the two parts. One is chemical equilibrium and another is ionic equilibrium. This chemical equilibrium has been divided into chemical and physical, and then chemical has dependent upon the effect of temperature, pressure, concentration, catalyst, and the physical like phase transformations. That are the things we have studied in the chemical equilibrium. And in this video, especially if I talk about the ionic equilibrium, what is the meaning of this ionic equilibrium? This topic will be related from ionic equilibrium. If I talk about the ionic word, ions, I hope all the students know what is ions, right? When any compound we break, it dissociates, or when we mix into the aqueous solution, it dissociates into the cation and anion. These things we have studied in the class 10 also. In class 10 there was a chapter called acid, base and salt. In that we have studied about the Arrhenius acid, Arrhenius base, Lowry-Bronsted acid base theory, and Lewis acid base theory, and many more we have things we have studied in the 10th standard. But same thing if I talk about here in the ionic equilibrium, this equilibrium is especially related to the ions, and the ions can be found in the acid, it can be found in the base, it can be found in the salt, and if I talk about the main thing, that is electrolyte. In this whole video we will discuss about the ions only. So let's begin with the introduction of ionic equilibrium. The earliest classification of the substance into acid and bases where depends upon the characteristics and properties possessed by each one of them. As for example, if I talk about acid, so you know, in acid generally from the beginning of the classes like 6th standard, 7th standard, we have studied what is acid. The substance which are solidest, or the substance which can conduct the electricity, or substance which can react with metal and give the evolvement of hydrogen gases. We can see it has a sour in taste. We can see with the properties which we have studied in the previous standards, about acid and base, right? So here if I talk about acid and base, the two things, if you divide acid and base according to the properties also, then what things you can write, you know very well. If I talk about acid, so first thing you know very well, sour in taste, right? If I talk about the taste, everybody likes the taste. So acid is sour in taste and bases are bitter in taste, right? Now second thing, do acid conduct electricity? Yes, it conducts electricity. And if I talk about base, then you will think that base do not conduct electricity. But remember, dear students, when there is ions in any compound, then that compound will conduct electricity. So here bases also conduct electricity. Okay. Now the third thing, if I talk about the acids, can you tell me what is the pH value of acid? Acid's pH is less than 7. Is less than 7. Right? And if I talk about the base's pH, then the pH of bases are more than 7 and less than 14. Right? See, these are all the things we know very well. I am not writing a very great thing or another thing. Now question is, can you tell me about some active metals by which the hydrogen gas means hydrogen gas is evolved. Any element or metal by which the acid is reacting and it is giving or it is evolving the hydrogen gas, it reacts with active metals and give hydrogen gas. If you want to write this thing, then you can write. Otherwise, if I talk about the litmus paper, yes, litmus paper, it turns the red litmus to blue and blue litmus to red. Basis turns blue litmus to red, and basis turns red litmus to blue and blue litmus to red acid turns, right? Yes. In basis, what you have to give? Acid and base, if you are checking, then you know very well. If I talk about just simple thing, litmus paper you know very well. It turns red litmus to blue, right? Red to blue and this turns blue to red, right? It reacts with base and gives salt and water. Here also it reacts with acid and give salt and water. Now what you have seen here is, these are the general things which we have studied in the junior standards. These are all the things I hope all the students know also. But as we talk about our 11th standard ionic equilibrium, this is especially about the solution when the concentration or the direction of equilibrium incidentally come across in the equilibrium, then there are numerous equilibria which involve ions. If you have studied about the equilibria, then you know the aqueous solution of sugar does not conduct electricity. Now the common salt is added to the water, it conducts electricity. Now the conductance of electricity increases with the increases in concentration of common salt. Michael Faraday, have you heard the word Michael Faraday? Has classified the substance into the two categories on the basis of their ability to conduct electricity. One category of the substances are called electrolytes, while other are referred as non-electrolytes. See, dear student, if I talk about directly this Michael Faraday, what he has done, he has directly divided the substances into the electrolytes and non-electrolytes. Electrolytes which have ions which can conduct electricity. Have you ever seen, just suppose, the mineral water, or you can say distilled water, not mineral water also, I am talking about the distilled water. Distilled water whose pH value is 7, means it is a neutral, neither acidic nor basic. But after electrolysis it will convert into H plus and OH minus. But when the water compound is there, that time neither it is in the H plus nor in the OH minus, because it is a compound and you can see a compound liquid is existing. Now if I talk about, if I put the water into the electricity board, will it fuse? Distilled water, not the water which we are drinking, neither the tap water, nor I am talking about the drinking water. If I talk about distilled water do not have any ions. And if it do not have any ions, then it will not conduct electricity. It is a bad conductor of electricity. Now question is, sir, how can you say the water which we are drinking, they have a lot of ions? The water by which we are washing our clothes, vessels and etc. So that water also contain ions. If water is containing ion, then it will conduct electricity. So what Michael Faraday has divided, sugar solution, sarbat, yeah, if you are taking that sugar solution and you are passing electricity, it will not conduct electricity, the bulb will not glow. Why it will not glow, If you divide this sugar solution, then it will break down into the glucose and fructose. Sucrose will break down into the glucose and fructose. But here, if you are dissolving the sugar into the water, it is not breaking down into the ions. But if you mix salt into the water, then it is dissociating. That water will conduct electricity. So what Michael Faraday has done, Michael Faraday has classified this thing into the two parts. One is electrolytes, another is non-electrolytes, means which conduct electricity, electrolytes, which do not conduct electricity, non-electrolytes. Now in the ionic equilibrium, especially if we talk about electrolytes only, right? So here we will begin with acid-base theories. Acid-base theory, why I am talking about? Because you have seen in class 10 also that when any chemical species, if I talk about the Arrhenius equation, if I talk about the Lowry-Bronsted equation, if I talk about the Lewis-base theory, then also there are the words which is called ions. So if I talk about the ions, then we have to go from the basic, that is Arrhenius acid-base theory. Means in this whole ionic equilibrium, we are going to discuss about the cations and anions, and cation and anions will begin from acid, base and salt. So let's start acid, base and salt. Now, if I talk about the acids, so can you tell me the define of Arrhenius acid? He was the first scientist who has given his acid-base theory. Can you tell me what is the define of Arrhenius acid? The chemical species which dissociate hydrogen ion in aqueous solution. The chemical species which dissociate hydrogen ion in aqueous solution is called Arrhenius acid. Similarly, the chemical species which dissociate hydroxide ion in aqueous solution is called Arrhenius base. Remember the word. It is dissociating into the aqueous solution, means in water, in aqueous solution, when you put any chemical species and it is dissociating hydrogen ion, it will be known as acid, and if it is dissociating hydroxide ion, it will be known as base. So according to Arrhenius, now if I talk about according to Arrhenius, the chemical species which dissociate H plus ion in aqueous solution is called acid. Now if I talk about if I talk about the examples of this acid, then HCl, when you will put this HCl into the water, then this HCl will dissociate into H plus and Cl minus. So if it is giving you H plus, then remember this is Arrhenius acid. Similarly, HNO3, nitric acid, when you will dissolve this nitric acid into the water or aqueous solution, then it will be H plus plus NO3 minus. Here, one student was asking, sir, what is the difference between the aqueous solution and water? Say, sometimes what are the basic things we should know? Aqueous solution is a neutral and water is not a neutral. Means just like distilled water and filtered water. Liquid is different in an aqueous is 100% pure. Purification is based on the quality, that which type of, when you go to buy a ghee, then there are some different rates ghee. You will see that it's written everywhere, pure ghee 400 rupees kg, pure ghee 600 rupees kg, pure ghee 1000 rupees kg. So you know very well that 400 rupees is also, that 1 liter or 1 kg of pure ghee is 400 rupees and another 1000 rupees. So you will think that what is the difference? Then you can say that, sir, quality will be the difference, right? Now if I talk about the quality, then quality how? You will separate this quality according to the ions, according to the what? Purification or pure materials, right? When I go to buy a marker, this marker, ink or marker, then I specially ask him, sir, please give me Camlin marker or Camlin ink. Why? The quality of camera is good and it is high rate. If you are thinking of quality good, then you have to pay extra. And general things, in 25 rupees ink is also coming, but that ink is not like this inks. Similarly, if I talk about solutions in aqueous and water, so I hope that quality and quantity you have understood. Now, if I talk about the Arrhenius base, then how you will tell that Arrhenius base? Arrhenius base is the chemical species which dissociate hydroxide ion in aqueous solution is called base. Now, if I talk about the examples of this base, then you can see here NaOH. If you give this NaOH into the aqueous solution, it will dissociate into Na plus and OH minus. Since it is giving this OH minus ion, then remember this is a base according to the Arrhenius. Okay. Similarly, KOH. If you mix this KOH into the aqueous solution, K plus and OH minus. So since it is giving OH minus, that's why it is a base. So according to the Arrhenius has given a concept that when there is a distribution of this compounds into the ions, especially H plus ion and OH minus, then you can say that this is acid and this is base. But what is the uses of this acid base ions into this ionic equilibrium? You can ask me, sir, tell me please, what is the, when you will mix this both the things, the salt, common salt, that neutralization reaction is HCl plus NaOH. When you mix this both, strong acid and strong base, you will get NaCl, that is a little solid H2O, right? Why I am telling you these all things? Because these ions are going to convert into strong electrolytes and weak electrolytes. Now, you will be able to understand that these ions are having some tendency or not. These ions can be stabilized, can be equilibrium or not. Because this chapter or topic name is Ionic Equilibrium. Now here question you can ask, sir, really, sir, what is the uses of this acid, base or salt in this chapter or whatever you have taught here, the chemical species which dissociate hydrogen ion in aqueous solution, acid and base, as you have given also. Now, you know very well this, all the things are widespread occurrence in this nature, right? Now, after understanding the concept that what is acid and what is Arrhenius acid and base, so now you can see that, sir, acid gives H plus ion and OH minus ion base will give, according to the Arrhenius. So now you can ask me, sir, what happens to this H plus ion, right? You can ask me here, sir, what happens to this H plus ion? This H plus ion mixes with this aqueous H2O and it converts into H3O plus. This is called hydronium ion. Hydronium ion. Have you heard this word? Yeah, you may have heard in the 10th standard or in the previous standard also you may have heard about this. So according to the Arrhenius concept, means any chemical species which is dissociating hydrogen ion in aqueous solution, then that chemical species is acid, and any chemical species which is dissociating hydroxide ion into the aqueous solution, that chemical species is base. Hope all of you understand. Now after understanding this concept, now what will be the structure of this hydronium ion? Control. Trigonal pyramidal. Trigonal pyramidal. Why I am talking about the structure? Because a bare proton, H plus ion, is very reactive and it cannot exist freely in aqueous solution. That's why it bonds to the oxygen atom of a solvent water molecule to give a trigonal pyramidal structure of hydronium ion, that is H into H2O plus, that is called you can say hydronium ion to that, and it is an aqueous solution. So hydrated proton mixed with this hydronium or mixed with this water or aqueous solution and converts into hydronium. Similarly, if I talk about the OH also, then OH also, the hydroxyl ion also exists in hydrated form in the aqueous solution. And Arrhenius concept of acid base, however, we suffer with this Arrhenius concept that in the base what the things had happened. Then if I talk about, it does not account for the basicity of the substances like ammonia, which do not possess a hydroxyl group. So this was the main concept about Arrhenius acid and base. Now, Lowry-Bronsted theory. What is Lowry-Bronsted acid-base theory? If you have heard about the Lowry-Bronsted acid-base theory, then it's very easy to understand this concept of Arrhenius also, and similarly we can understand about the Lowry-Bronsted, because the things which are back is H plus ion. If you are talking about hydronium or H plus ion, then it will be very easy to understand the concept of Lowry-Bronsted. Lowry-Bronsted had said that when any chemical species gives photon ion, photon means H plus ion, it is acid, and when it takes H plus ion, when it absorbs H plus ion, when it mixes with H plus ion, then that is base. Means proton donor is acid and proton acceptor is base, according to the Bronsted and Lowry theory. So here, just suppose, according to the Bronsted-Lowry theory, any chemical species, any So the concept is clear between this acid base of Lowry-Bronsted. What Bronsted had said, that proton donor and proton acceptor. Proton donor which dissociate or which donates the proton. The chemical species which donates the proton is called, what is called? Proton donor are called acid and proton acceptor are called base. Now you can ask me, sir, according to the Arrhenius, what is ammonia? This is the limitations of Arrhenius acid-base theory. So Lowry-Bronsted had caught this and he had divided the substance according to the proton donor and proton acceptor. So if you talk about the proton donor and proton acceptor, then you can say proton donor are acid and proton acceptors are base according to the Lowry-Bronsted theory. So whenever you talk about these all the things, Lowry-Bronsted acid-base theory, that time you have to remember in your mind that it is dissociating or it is means accepting or dissociating. Now question is about the conjugate, conjugate acid-base pair. Now if I talk about the acid-base pair that differs only by one proton is called conjugate acid-base pair. Therefore hydroxide ion is called the conjugate base. of an acid H2O and NH4 plus is called conjugate acid of the base NH3 if the Bronsted acid is a strong acid and its conjugate base is a weak base and vice versa. See, the things which you should remember is conjugate acid base. Lowry-Bronsted has given only the proton donor and proton acceptor. The base which accepts conjugate means what? भाई ये इसको न्यूट्रलाइज कर देता है, ये इसको न्यूट्रलाइज करता है, एसिड को जो बेस न्यूट्रलाइज कर दे, जो बेस को एसिड जो न्यूट्रलाइज, conjugate acid base and vice versa. So the remembering word is about the conjugate base is weak base and conjugate acid is strong acid. Similarly, conjugate acid is weak acid and conjugate base will be the strong. In vice versa, remember the word only, that is the adding of proton and removing of proton. There is a question in NCERT, that is 7.30 and 7.12. If you go through that 7.12 question, what will be the conjugate basis for the following Bronsted acid? Hydrogen fluoride, sulfuric acid H2SO4 and carbonate and HCO3 minus. The conjugate base should have one proton less in each case. Therefore, corresponding conjugate bases are F minus, H2SO4 minus and CO3 2 minus. See here, conjugate base HF hydrogen fluoride. इसके पास क्या होना चाहिए? Means conjugate base, if I talk about F minus will be there, then here H will be attached and it will become hydrogen fluoride. Similarly, if I talk about H2SO4, H2SO4 should have one less hydrogen ion, so it must be like HSO4 minus. ये इसका conjugate base. Similarly, if I talk about HCO3 minus, then it will be converted in CO3 2 minus. Means it should have at least less photon ion, then only it will be called conjugate base, or similarly vice versa of acids. So this was Lowry-Bronsted theory. This is the problem number 7.12, and 7.13 is write the conjugate acid. Now you have to write the conjugate acid of NH2 minus, NH3 and HCOO minus. The conjugate acid should have one extra proton in each case, and therefore the corresponding conjugate acid for NH2 minus. If I talk about NH2 minus, then conjugate acid will be NH3. If I talk about NH3, then it will be NH4 plus. If I talk about COOH minus, then it will be HCOOH. So you should remember that conjugate acid and conjugate base in the Lowry-Bronsted acid base theory. You should not see, these all the things are very easy. I hope that all of you know and you should understand about this conjugate acid base theory. The same numerical is also there. The main thing was given by Lewis acid and bases. Lewis acid and bases. Why I am talking about Lewis acid and bases? Because when the question comes of electrons, the whole matter is finished. Chemistry is experimental subject, and electron is a dynamic particle. Anything when it comes directly to the electron particle, means it is a, you can say, subatomic particles it is. It has been divided into many small particles. So when it comes to, the question comes to directly to the electron, proton or neutron, that time the question is finished. Means now it will not take a long period to move ahead. So when the question comes directly, so according to the Arrhenius, he has given that hydrogen ion and hydroxide ion. According to Lowry-Bronsted, he had given photon ion donor and photon ion acceptor. Now Lewis directly said electron pair donor, electron, not about the hydrogen, not about the hydroxide. He has directly said about the electron pair. G.N. Lewis in 1923 defined an acid as a species which accepts the electron pair and basis which donates electron pair. Which accepts an electron pair, anything which accepts an electron pair is called acid. And if I talk about the base which donates an electron pair, see, this is all the concept. Now according to G.N. Lewis, which donates and accepts. Donates and accepts का मतलब क्या होगा? It means it is giving and it is taking, right? It is giving and taking, means acid as a species which accepts the electron. You may have seen Cl minus. Cl minus means chlorine can accept one electron. So Cl minus is acid. If I talk about BF3 and NH3, A typical example of this electron deficient species, BF3 when mixed with NH3 it will become BF3NH3. Electron deficient compound like AlCl3, CO3 plus, these are the electron deficient compounds. Mg2 plus. Lewis acid, while species like H2O, NH3, OH minus, these are the donates a pair of electron and called Lewis base. कोई भी compound जो electron pair donate करेगा, electron pair donator, electron pair acceptor and electron pair donator. Donor, electron pair donor base, and electron pair receptor acid. Remember this code according to G. N. Lewis. G. N. 1923, the main greatest scientist of this acid base. Here this acid base theory completes. Any example you can take, lots of examples are there. And any single element also, if I talk about Mg2 plus, now you can see here Mg2 plus has donates two electron, a pair of electrons, so pair of electron donor is base, right? Pair of electron donor is base. And if I talk about acid like CO3 plus or AlCl3 plus, aluminum, from the aluminum this Cl3 plus or AlCl3. So here chlorine had accepted 3 electrons. You can say a pair of electron acceptor, so it will be acid. So remember the word about this electron pair donor and electron pair acceptor. I hope that acid base theory will be finished here. In the next video we will talk about the electrolytes, that how these ions are related to these electrolytes. We will talk about the strong electrolytes, we will talk about the weak electrolytes, how these weak electrolytes are converting into the ions and they are conforming the ionic equilibrium state, how they are existing. These are all the things we will study in the next video. In this video it was only the concepts of acid, base and salts by the Arrhenius theory, Lowry-Bronsted theory and G. N. Lewis theory. That's all for today. Hope all of you have understand the concept. Thank you very much. If you have not liked and subscribed my channel, then don't forget to like and subscribe the channel. That's all for today. Thank you very much.